So we should probably talk about how this vaccine works and also talk about side effects. And it's actually kind of worthwhile pairing those things together, because I think once you understand how a vaccine works, you can begin to understand a little bit of what you can expect from side effects that are actually maybe just kind of part of the normal process of developing immunity. So the way that we'll talk specifically about the Pfizer vaccine and what it does, but in general, it's important for people to understand when we talk about their immune system, they actually have kind of two components. And I'm gonna work in a sports analogy so that Mike Glenn will be happy as well here. But you have kind of your innate immunity and what we call your adaptive immunity. And your innate immunity is if something weird ends up in your body is going to react to it and try and get rid of it. And it's kind of like it's zone defense. All right. So if you're used to playing basketball or soccer or football, you know that your immune system is kind of covering an area, and if something comes in that area that's not supposed to be there, it's going to do something to defend against something that I don't know what it is, but it doesn't belong here, and I'm going to react. And so it has a bunch of different mechanisms. So
visual of Pac-Man in my head.
It has, you can have, yeah, it's, you got sort of things are kind of chopping up, and so whether it's a bacteria or it's a virus, your body reacts to it. Well, that sets up, it's sort of the sports analogy would be then it develops game film of what just happened, and then sets up your man-to-man defense for the future, because you recognize who the offending actor is. And this is our adaptive immunity. And when we talk about vaccines, this is the part of our immune system that we're actually trying to activate. And it becomes when we hear about things like antibodies, what antibodies are these proteins that are directed to specific types of viruses and bacteria in particular that we can use to defend. And they are really kind of personalized for each different infection. So it's an amazing system that we have in our bodies that does this every day. Our body is constantly reacting and developing immunity and protecting ourselves, and we have no idea it's kind of going on in the background most of the time. What vaccine technology does is it allows us to create a game plan to fight an infection without actually getting the infection. And so for years, all the vaccines that we have this kind of common theme, which is we try to show our immune systems something that either looks a lot like or is a piece of it, of a type of infection we want to prevent in the future. And we want to create these antibodies. We want to create this memory in our immune system so that if we ever come into contact with the real infection, our body is prepared to fight it and prevent the infection in a very effective way. So the Pfizer vaccine is a what we call an mRNA virus, and the mRNA stands for messenger RNA. And we all have lots of messenger RNA right now in our cells in our body running around. It's an important piece of our cellular machinery. And what the mRNA does is it provides a message. And so as I wrote in my frequently asked questions, I kind of think of it as a recipe out of a cookbook. So our DNA is the cookbook. It has all the recipes for all the things our cells need to do. Well, at any one time, our cells don't need to use all of that. So they just kind of take little copies or kind of photocopies of a recipe here, a recipe there to make things that our body needs. What we're doing with the mRNA vaccine is the vaccine has this little snippet of information that once injected, either your muscle cells or some of your immune cells will take up into their own cells, and we'll look at it like it's any other mRNA, and it'll say, oh, look at this recipe right here. I better make this protein that is in the recipe. And so the mRNA doesn't last very long, so it kind of goes in the shred bin right after it gets utilized, but it creates this protein. And the protein it's going to make for coronavirus is this spike protein. And after your body makes it in the cell, it gets exported either to the outside the cell or probably to the surface of the cell. And your immune system does that, hey, what's that thing that's, around here? That's not supposed to be there. And it begins this whole cycle of starting to create an immune reaction so that you can begin to develop this memory. So your zone defense gets kind of activated at first, goes and responds, and then is going to go make game film and create a plan so that in the future you'll have antibodies against the spike protein. And antibodies and cells that can recognize the spike protein is important because it's the spike protein that the coronavirus uses to actually invade your cells. So if we can neutralize that part of the virus's weaponry, then we can prevent infection. So that's basically kind of the both sports and cooking analogies. I mean, it's perfect. It's like two things I love.
There was a lot of metaphors in there, Dr. Mattern.
Both the answer here.
I think that when you think about how the vaccine works, it really explains some of what we would expect to see from a side effect profile. And I think the probably the biggest question people will ask is, can I get COVID from this vaccine? And you absolutely can't, because this is, remember, just a tiny piece of genetic material and not any actual virus. It is just creating a small protein that then your body is reacting to. But that reacting process, is the reason that your arm would get sore, that when your immune system gets flared up, it's the reason that you might feel have a low-grade fever or get a headache or feel muscle aches. These are the same kinds of side effects that we see in children when we give them their routine vaccinations, the same kind of things that make your arm sore when you get your tetanus booster. So the large majority of the side effect profile that we've seen with this vaccine is all related to that very expected immune response.
I'll just share that the data in the Pfizer study showed us that the likelihood of having those kinds of side effects that you're talking about, in some ways expected kinds of side effects, it's kind of a good sign. Actually, that means that your immune system is engaged and that your immune system is responding to that little antigen that's there, or that spike protein that Dr. Mattern was talking about. Along those same lines, what we saw in the literature was that the frequency of side effects went up a little bit for the second dose compared to the first dose, in as much as it's not the worst idea in the world to take the day off after you get the vaccine, or prepare for it if you're a shift worker, to have it be at the sort of tail end of your shift in case you feel kind of crummy after. But speaking again to that concept for myself, the 4 stages of grief that I've gone through with COVID in general, and my skeptic to acceptance with the COVID vaccine, that whole business, actually realizing that this was the biology of this vaccine is so unbelievably familiar to the other kinds of biology around vaccines that have been on the market so much longer, has given me actually quite a bit of confidence and quite a bit more security in this particular vaccine.
Yeah, I think it's important to acknowledge that this is probably the thing that people fear the most, is a side effect in the short run. And I think for those common side effects, it's important to know they only lasted a couple of days, and that also they actually measured how many people decided to take like a Tylenol or a ibuprofen, and about 25% of people after the first dose kind of thought something required doing that, and then about 50% after the second dose. But these were short-lived; they go away. One of the things that people worry about are kind of more long-term side effects, and when we activate the immune system, could it create unusual reactions or problems? And because we're we have a smaller population, rare things might not happen until it's in a larger population. But we always have to make decisions about risk and benefit. And right now, the known risk is that the likelihood of contracting coronavirus and the likelihood of getting very sick from coronavirus far outweighs potentially side effects that may be 1 in 50,000, 1 in 100,000 or more. And so when the EUA is authorized, it will really be with that in mind, but there'll be a process to collect data to find out if there are some things that are more unusual over time. And it's the thing that we don't know, but what we do know for now is that we're in a global pandemic, and not doing this has a cost too. So,
and frankly, who wants to travel again?
yeah, everyone needs a vacation, so there's that too.